Tesla has reinvented the art of global manufacturing by creating a network of gigafactories that function like living organisms, each adapted to its local ecosystem, but sharing the same DNA of radical innovation. This industrial journey began with a bold bet: to prove that electric vehicles could be mass-produced with greater efficiency than combustion engines. The result is a mosaic of facilities where precision engineering, cultural adaptation, and a forward-looking vision intertwine in unique ways on every continent. At the heart of China, the Shanghai Gigafactory emerges as a masterpiece of spatial optimization. In a land where space is a precious commodity, the factory turned constraints into a competitive advantage. Its corridors are choreographies of efficiency, the office suspended above the assembly line, mobile containers dancing between machines, cafeterias strategically positioned as productivity oases. Every 40 seconds, a complete Model Y rolls off the production line, a pace that would make Henry Ford blush. But behind this industrial mastery lies a symphony of factors, a skilled workforce that embraced Tesla-esque culture, local suppliers integrated as extensions of the complex itself, and a symbiotic relationship with authorities who saw the factory as a bridge to the future of Asian mobility. Crossing the globe to Germany reveals a different chapter in Tesla's saga. In Grünheide, the Berlin-Brandenburg Gigafactory faced the European paradox: how to reconcile disruptive innovation with centuries-old industrial tradition. The challenges were epic, from debates about protecting rare lizards to legal battles over water usage. Each obstacle became a catalyst for creative solutions: water recycling systems that transform 6,000 m³ of daily water into a closed circuit, partnerships with renewable energy sources that power machines with Baltic winds, and a workforce that blends German rigor with Silicon Valley agility. The reward came in numbers: a 65% productivity gain in 3 months, production of 500,000 vehicles in record time, and a Model Y that reaches European customers free from the shackles of import tariffs. In Texas, the Austin Gigafactory tells the story of boundless ambition. Built on land that once housed cattle ranchers, the facility is a physical manifesto of Elon Musk's vision. Its giant 9,000-ton presses spit out single-piece aluminum parts that reduce hundreds of components to monolithic structures. The Cybertunnel, a 400-meter tunnel beneath the highway, is not just an architectural curiosity, but a pragmatic solution for logistics on a continental scale. Here, efficiency is measured not only in vehicles per hour, but in the ability to iterate processes in real time. Robots that learn from each weld, algorithms that predict bottlenecks before they arise, teams that challenge conventions in search of the ultimate assembly line. What emerges from this global web is a living laboratory for 21st century manufacturing. Shanghai shows how operational maturity and extreme optimization can squeeze every cent of efficiency. Berlin proves that strict regulations can, paradoxically, force technological leaps. Texas demonstrates that continental scale allows for bold experimentation. Together they form an ecosystem where every advance on one continent feeds improvements on the others. The numbers tell part of the story: 750,000 vehicles per year in Shanghai, 500,000 in Berlin, expansion to 1 million planned. But the real revolution lies in the invisible details: the water that circulates endlessly through German pipes, the containers that become mobile warehouses in China, the Texas algorithms that predict failures before they happen. These micro-efficiencies, when added up, redefine what's possible in the automotive industry. The human challenge is equally fascinating. In Shanghai, subsidized cafeterias and on-site dormitories create a community dedicated 24/7. In Germany, unions and management negotiate a delicate balance between productivity and workers' rights. In Texas, engineers recruited from aerospace industries bring a mission-critical mindset. Each model reflects the local culture, but all share Tesla's obsession with continuous improvement. The quest for sustainability adds another layer of complexity. The gigafactories are simultaneously voracious consumers of resources and laboratories for circular economy. Berlin spends $450 million on water systems, but reduces consumption by 35%. Nevada turns battery waste into secondary raw material. Texas integrates solar energy directly into its processes. Each local solution becomes a global case study. Looking ahead, the next frontier is vertical integration. The production of 4680 batteries in Berlin, once started, promises to reduce the logistical dance of cells coming from Asia. Austin's giant casting could inspire Shanghai to unify even more components. Each technological advance spreads through the network like a beneficial virus, raising the bar for the entire system. Behind these walls of concrete and steel, a silent war against time and inefficiency unfolds. Shanghai managers sleep with tablets showing real-time data. Berlin engineers adjust robots during night shifts. Texas planners map material flows in virtual reality. These are daily battles for fractions of a second, for pennies saved, for watts preserved. For the North American consumer, this global network means more than affordable electric cars. It is the guarantee that their Model Y came from a factory that is redefining environmental standards. It's the assurance that the battery in their Cybertruck incorporates lessons learned on 3 continents. It's the promise that every innovation in efficiency translates into greater range, lower cost, and a more sustainable future. The final lesson from these gigafactories transcends the automotive industry. It shows that in the era of globalization 4.0, efficiency is not about standardization, but about intelligent adaptation. That environmental constraints can be transformed into competitive advantages. That the key to scaling disruptive technologies lies in networks of factories that learn from each other, each writing its own chapter in the manufacturing manual of the future. As the electric revolution accelerates, these industrial cathedrals will stand as witnesses to an essential truth. In the 21st century, maximum efficiency requires both artificial intelligence and human adaptation, both global planning and local sensitivity. And in this delicate balance, Tesla continues to write its treatise on how to reinvent the wheel, literally on a planetary scale.